Hello. Bit of flying by the seat of my pants today. Can you hear me? Can you see me? Excellent connection to YouTube. Great. Awesome. Everybody say hi in the chats for me so that we know chats are working. Malco from YouTube, thank you. All okay there. Mark says live on Twitch. Bruce S says live on the tubes. Great. Awesome. I was a little behind schedule. David says good afternoon from Twitch. Thank you, David. Awesome, 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 awesome. You all are awesome. Emmett says hello. David says hello from YouTube as well. MD Roberts says hello. Great. Victory Habit says hello from Twitter. Zach asks, what up on YouTube? Awesome. Thank you all for joining me. That's right. I popped this one out. Managing all my windows. I gotta set up all my windows every time because I don't think the Linux OBS has embedded browser support yet. So I actually do like window captures of all the different chats and stuff. Charles says, good day. Where did my Discord window go? Oh, you know what? I closed Discord. That's why I've got so much room. I've got the some Twitch latency. Is the video buffering? Use the low latency toggle under the advanced menu and settings to disable low latency mode. YouTube should be okay. I think I remembered to set that setting. Let me start Discord back up because I forgot. I failed to do that. Okay, there we go. All right. Good, 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 good. And that can go there. Oh, yay. Awesome. I just got an email from Oshpark saying that the Stemma QT board I designed, which did I show off on the stream? Have I showed you that yet? It's just back from Fab, which I was wondering because I'm very excited to get back into. Emmett asks, will there be any live stream about ARM SimSys? I don't know much about ARM SimSys itself. If you have more specific questions than that, let me know. I might know the answers to those, but ARM SimSys is a broad topic. I don't really have a lot of stuff about, a lot of knowledge of. I tend to work at kind of like the register level more than I do the SimSys level, I guess. So. Awesome. Everything's going great. I've successfully procrastinated. Given some time for folks who are, if they're a little late. But yeah, Emma, if you have questions, feel free to ask them. Let me get going. Hello, everybody. My name is Scott. I work for Adafruit on CircuitPython. Adafruit is an open source hardware and software company based out of New York. They sell hardware as their business model. So if you like what Adafruit's doing, including the open source software that we create, please support Adafruit by buying hardware at adafruit.com. Hi, Unexpected Maker. Hi, Generation. He says, it's good to see you live. Yes, live. It's great. And it just started raining here. I'm in Seattle, and we've had lots of smoke. So they've been telling us to stay inside because the smoke from the wildfires were so bad. But it's raining right now, which means that it's collecting all that smoke and bringing it down to the ground, which is great. And hopefully by Sunday, the air quality will be better, which will be awesome. Yeah, so Adafruit CircuitPython. So CircuitPython is a fork of MicroPython. It's Python designed for small, inexpensive computers called microcontrollers. They come on boards kind of like this one. And if I cover my face, it'll autofocus there. Unexpected Maker says, how's the kitty? I didn't hear what the vet visit was for. Everything okay? So I did have a vet visit. So I have 2 cats, and this is a good housekeeping. Vin, the girl, is pretty normal, but she's had some dental issues. So she's got like pretty poorly, like we don't do any teeth brushing or anything for her. So she's got some teeth issues. So the vet that I just had this week, I think it was this week. When was it? I don't know. Tuesday. She had to go get checked out because they're gonna put her under anesthesia to clean all of her teeth. And they also wanted to check her out and see what they were gonna have to do. They discovered she's missing half of one of her back teeth, and so they've got to take the other half out. So she's actually gonna have some oral surgery, which reminds me, I meant to call the vet today and schedule that, but I've forgotten all week. But she's okay. And then the other cat is Spook, who you can actually see in the kitty cam here, and I'll switch to it. Cat cam. So that's Spook. He's giving himself a bath right now. Usually he's just asleep, so this is exciting. This is excitement for this stream. They're brother and sister, and he is epileptic. So he has seizures from time to time. We just switched his meds, and this is the first day he's off his old med. So the housekeeping that I like to do is just in case he has a seizure, I'll just like mute my audio and just kind of be standing here and watching him just to make sure that he's okay. But besides that, things are good, I would say. He has clearly a terrible life. Sitting in the window every day. Although it's rainy, he would prefer it to be sunny, I'm sure. Bruce says, our rain earlier in the week only dipped the smoke. It has returned. Yeah, that's true. I think I'm hopeful that this will be... Oh, yeah, I'm watching the wrong channel. Hi, Jim. I missed you. I think I missed you earlier. I think the idea is that this rain is going to be more significant, and there's a like weather system coming in after it that will hopefully clear out the smoke for a while at least. You're fine, bro. The little guy is important. Yeah, he's a much more expensive cat than we thought he would be when we first got him, but he's quite cute and loving, so it's all good. Okay. This is not usually, well, I was going to say this is not usually a stream about cats, but that's not quite true. It is a topic that we cover pretty regularly. Let me switch away from cat cam and give you an overview of what we're going to talk about today. Thanks for all for hanging out. As always, if you have questions about CircuitPython or embedded or things that you think I might actually know about, like how the cats are, feel free to ask those throughout the 2 hours or so that I stream. We do it as a deep dive. It tends to be like the first half hour is kind of like a smattering of things that I'm thinking about, and then we do kind of a bigger topic at the end of the stream. I think today is going to be a bit more of the first than the second thing. This whole week for me has been characterized kind of more by like a scattering of stuff. I'm basically trying to, yeah, you like this camera? Or is that the picture that you're talking about, Midnight Cookies? I was on Show and Tell on Wednesday, and people were like, this camera is awesome. I just got this new Sony ZV-1. So I'll talk about this kind of smattering of things that I did this week. There's a few things that we could kind of pick up on. One thing I do want to hit on is, good. You like this camera. Great. Yeah, I'm really, really happy with it. I just got it a couple of weeks ago, and it does eye tracking. So like the view that I can see here is like drawing a box around one of my eyes. And you can actually tell it which of your two eyes it should follow. And it has this product mode, which it's not in, but I have it on this button here. Like so this is product showcase mode. So if I just hold up a thing, it does like a nice quick zoom to it, which is awesome and been working really well. So I'm very happy with that. Yeah, so that's the Sony ZV-1. Maybe we should stock it at Adafruit. Hello, Barack, and hello, Fred from New York. It's the Sony ZV-1 for, it would be ZV-1 for you. And I put that there. Okay, so let me answer David G's question. David said, are you going to be doing a new release? Well, a release was something we were hoping to do this week, but the GitHub Actions kind of like got bottlenecked, and a lot of the PRs that are ready to go in, the CI is continuous integration. So every time we get a new commit, we run all the builds. So we build every single board for every single language to make sure it fits and make sure it compiles. And then we also run some tests as well. And there was so much happening at the end of this week that like that kind of got backlogged, and there must have been a hiccup with GitHub Actions where they throttled us because we were just doing too much. So we're a bit behind in getting everything in. So Dan's been working on the release. He's taking next week off. But one of the reasons I was late is that I was actually syncing up with him on where the release is at. And it's looking like it's going to happen on Monday. He's going to do a lot of the work, and then on Monday I'll finish it once we can get everything going. Awesome. So, okay. We've got more questions. So let me just talk about the other topics, and then maybe these will be interesting and people ask about them. So non-CircuitPython related is I have a PCIe Express kind of pinout that I want to use for boards that I want to get a lot of GPIO out of. I've got Anecdata just filed an issue that the Adafruit request library doesn't work on 5.3.1. So I've got some fixes there. We talked about the release. The other two things on my radar are the USB product IDs. So I actually merged a CI check-in this week that makes sure that we don't get duplicate USB IDs, which is good. And then the last thing is I've been revisiting the UF2 bootloader, which is our favorite bootloader, and we're bringing it to the ESP32-S2. So I want to talk about that as well. In fact, I'll tease ESP32-S2. Thank you. I'll tease it for Unexpected Maker. I think I'm going to try to get it going on the Feather S2 that I have here because I'm frustrated using the built-in bootloader on it. And I did actually, we've seen me have USB hub troubles. I actually did get, maybe I can use the overhead for this. I do have the overhead working, which is cool. I think I can tilt it this way. So if I flip, it'll make more sense this way. Although that was weird. It actually cut it off or positioned it differently. But I've got the Capable Robots programmable USB hub, which is a 2.0 USB hub, and Timon was suggesting that would actually be more reliable. And what's cool about this USB hub is that it actually runs CircuitPython. So there is actually a SAMD51 in this next to the hub chip that controls it as well. So that's an update on that. Okay, let's get crazy. There's lots of questions, which is awesome. So I'll switch back to my thing, and then I'll switch to the desktop if need be. So I answered the release question. Incorrect English. So Windringo says, I should ask this in the Discord instead of here, but would you ever do a live stream with an overview on how to contribute to CircuitPython? I want to try and help port it to Blue Pill in my free time. Yes. It's a complicated problem, and if you're talking about porting, it's a pretty big task. This whole series of live streams that I've been doing has kind of been like, I get distracted a lot, obviously, but it's been like progress on porting the ESP32-S2. So it's meant to be kind of collectively, how do you port something? I know for the Blue Pill in particular, I I think that's the right one that I'm thinking of, has an STM32F103, and it comes with an F103 that has like 20K of RAM and 128K of flash. I think I saw somebody just asking about this, and basically it's too small. Like that version of the F1 that comes on the blue pill is too small for CircuitPython. The smallest boards that smallest micros we support right now are the SAMD21s, and they're 32K RAM with 256K flash, and they're very tight. You can ask some folks who have already used it, and it's not that pleasant. It's a much better experience for like the SAMD50 that have 192K RAM and 512 or a megabyte of flash. So I think the blue pill will not be a great experience for folks. That being said, there is some work that Bruce S. is pointing out. There is some work on the F1s, but it's for the higher end F1s that have more flash and RAM. And if you want to help out with that, there's at least an issue, if not a PR. So if you want to help out with that, check that out. And you can always ping me on Discord if you have questions. I'm happy to help people get going. Fede2 Alvaro points out that the SNEC language could be ported to it. It can even work on 8-bit stuff as well. Soju, hello Scott, greetings from Guatemala. And we have folks from Turkey as well. Emmett Ray asks, are you using STM32 at all? I don't personally, but I like Hierophect Lucian, who works for Adafruit, kind of does all the STM CircuitPython support. Bruce says, international show, Scott is covering the world. Yeah, hopefully it's a reasonable time. Okay, there's more questions. I hope that answered it, Winged Rhino. You can always ping me on Discord if you have more questions. MD Roberts 1243 says, question, where in displayio is the actual set column, set row done to a display controller? Couldn't find it in a couple of attempts, and can you give me the 50,000 foot overview of the common HAL? Yes, I think some of this stuff we've covered before, but this is stuff that's very useful to cover multiple times because it's not simple. So let me switch to the desktop and I'll pull up the source on... I have too many browsers open. Let me pull up a Firefox here. And let's just talk... I'll reiterate the structure of CircuitPython because I think it's just helpful. Awesome. David says, this is a reasonable on Friday, not so much in the middle of the week. And Bruce S says, this is my end of week relax time. Yeah, I was actually thinking about doing some PCB design because that's kind of my non-work stuff. Okay, so let's talk about source layout a bit. I think more people watch this now than when I may have covered it in the past, so it's always good. I'm going to buzz you on Discord next week, and perhaps maybe a starting point is just figuring out Tiny USB. Tiny USB is always a good place to start. And I try not to respond on weekends, but if you want to set up a time, if anybody is like super busy during the week, but wants to meet up, but can meet up or discuss stuff on the weekend, I'm always happy to pre-arrange a time to talk on the weekend. I just don't want to be at my computer all weekend. So yeah, just hit me up on Discord and we could plan a time. Okay, so this is the source for CircuitPython. It's github.com/adafruit/CircuitPython. And there's also CircuitPython.readthedocs.io. There's a couple things here that I think are underutilized. They're also not well advertised. One is this design guide, and I pointed somebody to it recently. It's kind of a smattering of different philosophy, like pieces of philosophy for CircuitPython that I wrote most of this actually in like within the first year of doing CircuitPython. Start libraries with cookie cutter is just to like have a standard format for libraries. Module naming, prefix modules with Adafruit _ if it's funded by Adafruit, but if in general, like the person who owns it should be the like underscore prefix of a module. Use context managers because they're awesome. If you're doing a driver, like add verification that makes sure that you are talking to what you think you are talking to. Use properties instead of getters and setters. Design for compatibility with CPython. Here's how to document stuff. Use bus device for managing I2C and SPI transactions, which I think kind of answers. Emmett Ray asks, do you have your own framework to work with I2C and SPI protocols? Let's detour there. One is the bus device library is a really good thing for like kind of very high level, like there's a device on this protocol that we're talking to. And then the other bit for that is that we have a library called register. And it's a very declarative form of, so if the device you're talking to via SPI or I2C is basically like register, read value, set value, register, get value, blah, blah, blah. Like if it has that model, and most of them do, you can actually use this Adafruit register library to be more declarative on the way that you say what the device has. So here's an example here where it just says there's a readable and writable bit in register 0 at bit 0, and we call it hello. And then you can just say hello equals true, hello equals false on the device. So this, if I had to say what the framework for I2C and SPI is like actually register. And this model is also the one that I'm trying to bring to FPGAs as well. So like any register level interface will actually be like describable with data descriptors, which is what this approach uses. So yeah, that's kind of answering Emmett's question about frameworks for I2C and SPI. And then on another tangent, some people are debating open source versus free software. I started a book called Working in Public, and it's very related to what we're talking. Well, they talk about that a little bit. I'll just show the Amazon, and it's an inside look at modern open source software developers and their influence on our online social world. So it's talking about kind of like what you see me do like week to week on the stream as an open source software developer. So if you're interested in like the process of open source, I think this is a cool book. I'm still in the intro, so I can't say like overall it's great, but I'd recommend it. Check it out if that's interesting to you. Folknology asks, does BusIO support different SPI widths like quad or octo SPI? It does not. It does not. We support quad and dual for the SPI flash, but we don't expose that. Okay, sorry, I'm distracted. I'm like, three stack frames deep here. Design guide's really great. Talks about lots of just random philosophies. And then one thing, if you ever do drivers, we try to have standard property names for all the drivers. So you can see that here of like what the type is and the units, so that like you can replace drivers and not have to change your code. And then there's some stuff about adding native modules. And I actually also have this MicroPython thing that says like, if we can be compatible, we should be, but not to preclude any of these other things that I'm already talking about. The reason I wanted to talk about that is that there's also kind of this architecture discussion, which it doesn't look very useful. Let's see. That's not very useful as well. But the file layout is covered in here a bit, which is why I got over here anyway. So yeah, Emmett asks, what is your favorite book about electrical engineering? I don't actually have one. I've never read an electrical engineering book. I took two courses in college, and I don't remember what the book was. I have the Art of Electronics, and I've flipped through it, but I'm mostly a software person, so I haven't done it very much. Okay, so we're still answering MD Roberts' question about displayio, trying to find actual set column and set row. 50,000 foot overview of Common How. So this is the 50,000 foot overview of modules in CircuitPython. Shared bindings is the layer that goes from Python to C. So it does parsing structs that represent Python objects down to native C types, and also validation, like argument validation. And then there's two places that C level implementation stuff goes. It goes in shared modules if it's code that's agnostic to the microcontroller, meaning it could run on an NRF and an ESP. Then it would go in shared modules. If it can't, if it's specific to particular port, meaning like microcontroller family, then it goes in ports / like identifier for that port / common how. And then, and this is wrong. Modifying this build stuff is wrong. And there is a learn guide about this as well that is also slightly out of date. We've updated the way that we do our kind of build system a bit. Brack asks, is there any computer engineers among us? I'm actually technically, my degree is in computer engineering, which is why I took the 2 EE courses. But I wouldn't say that I've actually engineered a computer at all. I'm a software person, generally. I'm like very much in the software side of hardware. Okay, so let's take a look from the top level here. So, and I think we cover this. Yeah, so there is this a bit more information down here for project structure. Clearly it's out of date because our ports are not listed fully. So if you want to try just making a change, you could update this list, for example. But this goal is to kind of lay out what everything is, and I'll just go over it again. So devices is something new, and this is like C level code that's shared amongst stuff to talk to external devices. In particular, this is to talk to an ESP32 SPI in BLE mode, a separate ESP32 chip connected to the one that's running CircuitPython and using it as a BLE HCI device. Docs has a few docs in it, like the design guide, but generally it doesn't have a lot of documentation. Drivers and xmod are kind of inherited from MicroPython. We use some of the code in there, but we don't really add any new code because we prefer to structure things differently. Frozen has submodules in it that are Python, and those are the ones that like might be built into the binary itself. I love that the docs are mostly wrong. I'm sorry about that. We should update them. Docs are important. It's just things are always changing. Lib is any like C level libraries that we use plus some stuff that MicroPython just put there. Locale is where our translation files are. So both the circuitpython.pot file, which is the template file, and the PO files. Can you open the subtitles? I'm not sure what you mean by that. Should I make these bigger? Nobody wants to be the doc updater. Actually, on my to-do list, I have a guide to add one about UF2 ESP32-S2. So I will be writing a guide shortly about that. Logo is just some logo files. MPY cross, this is the binary that converts from Pi files to MPY files. That's in there. Ports is where all of the port specific stuff happens. And if we click there, you can see that we have a number of different folders for a number of different kind of like peripheral families. Pi, this is where kind of like the implementation of Python as its like Python part is done. And this is the part that we share kind of the most with MicroPython. We've done the least changes in this directory. It's kind of like the core Python VM in here. Shared bindings is our unique thing. As I said, it's the layer between Python and C. Shared modules is the shared C side of things. Supervisor is the like VM-y sorts of things. It's the C code that dictates what happens when your Python code's not running. So it manages like, oh, you wanted to reset everything, or you wanted to get into safe mode, or you wanted to connect to USB. Like it manages kind of all the things outside the VM. Tests are tests we inherited from MicroPython and have also rarely touched because they also do cover most of what's in the Pi directory. And tools is just a smattering of Python tools. One thing you'll also notice is that if you've ever looked at MicroPython source, one thing we've done is we've actually, in CircuitPython, we have one main.c. Last time I looked at MicroPython, they actually had a main.c per port. So kind of that and supervisor are the ways that we've tried to factor out things that are to make more stuff common across ports. So TwitchBot is there. We're 33 minutes in. Okay. I was raised as an intern who was used to updating docs and unit tests. Best way to teach someone stuff. Suggest doing the same here. Yeah, we'll take pull requests for updating docs. Editing wiki docs is scary. So if you wanted to help us with docs, we don't use the wiki, so you'd have to go through our pull request process, and I would just review it. So don't be scared. We'll get some other eyes on it before we commit it. Super easy to start. And also, one thing I've done that's works really well for me because I'm bad at documenting is I actually had a great like hour-long conversation with Carter about displayio, and then he wrote that guide that if you've used displayio, you've probably used this guide that covers like tile grids and like the philosophy and all that. So that was, if you ever have a topic that you think could use a written guide for, but you don't know all the information, you could snag me and we'll talk it over. And if you want to write it down, like that's well worth my time. So that's a standing offer. Okay, let's go one level down into this like triumvirate of common HAL, shared bindings, and shared module. So this is at this level, this is a standard file layout. So we're one level deep in shared bindings, and each one of these folders is equivalent to a module that you could import in CircuitPython. So you'd be able to say import digital IO, import gamepad, import GNSS if you're on this presence. So not all of these modules are available on all ports or all boards, but this is like all of them that we have support for. And we have some documentation glue. So shared bindings is the Python to C layer, and we also have documentation, Python style documentation, even though it's implemented in C as well. So what we do is we have Python stubs. So we have this special //bar prefix for comments that are actually Python stubs. So we just have a script that takes these files, strips everything that doesn't start with //bar, and then makes a Python stub file out of that. And then that's what generates all of the documentation here. Yeah, so these directories are critical if Emmett says, I love the C language. If you want, like Python is really good for iteration, right? But it's not necessarily good for fast execution. So knowing this structure of shared bindings, common HAL allows you to add C where you need it, which I think is super powerful and not enough people take advantage of it. But yeah, so that's these, all these docs here come from shared bindings. And then if we look, so there's kind of two levels of files, and this has just one of each. So this dunder C, dunder init. So dunder is the slang or the shortened term for like double underscore, which is special methods in Python. So the dunder init.c is really just declaring the C struct that represents the module, and then all of the names that live in that module. So Python's dictionary is basically everywhere. So this is, although it's a table, it's used to act like a dictionary, which is this variable name within the module maps to this object, which is a Q string is an inline string, so it's a string object. This is byte array maps to this type, which is like a class before you instantiate it. And then classes have their own file here, byte array, and it has all of the separate functions. So it has, is this a good example? It might not be a good example. No, this isn't a great example. So NVM byte array is a little weird in that all of its API is like using subscript. So that's why it supports like unary operators and subscript stuff. And it has a local dictionary, which I don't see. Oh, here it's empty. The locals dictionary is empty. Let's take a more typical example. So like, who was it? MD Roberts was asking about displayio. So let's start getting more specific here. So if we look in displayio, it has kind of two layers. It has display buses, which is like the protocol that you would talk from CircuitPython to a display, and then it has the display that talks over that bus. Juan Carlos asks, can you expand about what you just said about C in Python? In what sense? I can, but I don't know which direction you want me to go. Midnight Cookies is setting up their Edge badge. So let's take a look at display while we're waiting for Juan. So, and I actually do like, well, the comments are really helpful. Oh, yeah, you're right. Yeah, so I said you're talking about performance. So Python's strength is your ability to write and experiment and test with code really quickly. It's not as fast as C. It's never going to be as fast as C, right? Like C has the advantage of saying, what is all the code I need to run? And let me compile it down and then we'll run it. Whereas like Python has much less opportunity for optimization between here's my source code and here's what I'm running. So you will always be able to write faster code. The code you execute from C will always be faster than Python code that you execute. You'll be able to write the Python code faster, but the execution speed will be slower than C. So CircuitPython, MicroPython, they're great. CPython is great because you can do all the Python stuff you want until you realize that like this one function is your bottleneck. And then when you find that one function that's your bottleneck, you write that in C, you call it just like we're talking about now, and now you have mostly Python, but it's executing a lot faster because the critical piece, the critical path is now written in C. And this is actually how in CPython, which is desktop Python, like NumPy, for example, is really quick because it's all actually implemented in C. Is it slow because of all the libraries you have to import of Python? No, I think it's actually the way that it's executed. Like the way that Python code is executed is that it gets parsed down to bytecodes, and those bytecodes change the way C code runs. Which, if you want to get into it, if you're curious, I don't understand a lot of it, but I'll show you where that happens. So in the Py directory, Mark asks, does the C part have to be built into CircuitPython compiled? Yes, it does currently. Yes. There's been work upstream in MicroPython to allow for natively loaded modules. Um, I'm wary of that because it's going to be really tricky to manage because like what if you have a native module that's for ARM versus Extensa and like how does that work? Like ESP32 versus STM, for example, like those aren't going to be cross portable. But we are thinking that soon we're going to update to a newer version of MicroPython. Like they just released 1.13 that has the native module stuff in it. So we will inherit a lot of that in the future. Probably 7.0 will have it. So we will have it. I'm not sure I want to push people to use it, but it will be more available in the future. No, so the reason that Python runs slower is Python code gets interpreted to bytecodes, which you can see in bc0.h, I think it is. So you can see these definitions of MicroPython bytecode store fast n is operation 22. These are all the different things they could be. Great questions, everyone. So Mark says, yeah, I was thinking for libraries that are cross-portable. Wasn't thinking about libraries that are cross-portable, but that's a good point. And Juan Carlos said, would producing an MPY allow one to achieve C-level speed, or is that something else? So MPY converts Python source code to bytecodes. So it doesn't help you with execution speed at all. What it does help you with is it does help you with load time because you're like further along the process to begin with, and it helps you with the amount of memory you take when you load, right? So when it takes Python source code in, it's got to actually load the strings into memory and decide what they are, and then also create all of these structures. So there's like more memory use to do that versus importing an MPY file because it's like way closer to what the final in-memory representation is. So that's why on the SAMD21 in particular, we recommend MPY libraries, is that it just means that you can load more of them because that memory footprint to import is less. Now, the end result of the memory footprint should be about the same, but the peak usage will be different. Aaron from Twitter asks, at a high level, if possible, how do you isolate a slow Python section? That's a great question. I think the simplest answer is really to, I would just print. So like in CircuitPython, you have time.monotonic and time.monotonic nanoseconds. That will give you a pretty good idea of like how long something takes to run. Yeah, it's a tricky question. I think, using time.monotonic to measure is good. Folknology points out you can use a logic analyzer for I/O timing, so you could just like see how long, like if you're doing a SPI transmit, you can use an I/O logic analyzer to confirm that it's the baud rate you expect and see how long the transaction takes. And if there's like breaks in the transaction, like those breaks are when CircuitPython is doing something usually as well. Right. David says for MPY versus Pi, same VM, but you skip the compiler. Right. Awesome, Aaron. Aaron says that's what I was looking for. Thanks. So these are bytecodes, and then I'll just point, I don't know how it works that well, but there is in the Pi folder, there's a vm.c. So this might demystify it for you. But there literally is a for loop. Where is it? It's kind of hard to see. Yeah, here you go. There's an empty for loop on line 176. This is your VM. So every bytecode goes through, or maybe it's this one. There's two. I don't know why there's two. There's an outer exception handling loop. This is the part that I don't have a great grasp on, is the exception handling stuff is complicated, and I don't understand it that well. Luckily, the MicroPython folks understand it really well. But there's literally a for loop that is how the bytecode on Python is executed. So you can see here that like BC load const true pushes onto the stack the value of true and none and false. And then there's, so this is like loading values into your like locals dictionary. And it gets more and more complicated as you go along here. And there's like different ways that you could actually go through this loop and blah, blah, blah. But literally this is what is executing your code. It's C code that's running Python bytecodes. Whew. Okay. Right. David G says, in CircuitPython, you may want to write in C stuff that you need to run in the background in parallel with Python user code. Yeah, that's a good point, David. We don't have interrupt support in CircuitPython. Interrupts generally are, you get something into the CPU that says, stop what you're doing right now and do this other thing for me. And MicroPython has a way to like actually interleave Python code to do that. But that is like really hard to program. Like concurrency, where you can interrupt, like you can be in the middle of a chunk of what you think is linear code, but like have some other code run in the meantime, is like really hard to do. And so on the Python side, in CircuitPython, we don't allow you to do that. If you need that though, all of our C stuff is allowed to like actually do interrupts. So if you need interrupt support, write C code for CircuitPython instead. But a lot of our native libraries, like our native modules, like handle the things you would need interrupts for already. Okay, so we're talking displayio. This is a great question, and it seems to be engaging folks, so that's great. Okay, so we're looking for set column and set row. In the Java world, bytecode could be compiled into microprocessor instructions. Translate once, execute multiple times. Should be possible to boost things. Yeah, and MicroPython has this notion of like different emitters. Like they have a native emitter and a something else emitter. There's totally possible that we should be switching to that as well. But I haven't looked at it. Okay, so the other thing I should talk about, and somebody made KMatch98, I think was the person, made this great kind of infographic about naming. So we also try to have, within shared bindings, we try to have standardized naming for things. So if we just go to displayio, oh, I have this open already. Let's go back to this tab. So here we can see the Python version of this is what from Python it looks like. Bruce S says, so moving to MicroPython 1.13, does that get micro async IO? It does. We would get everything that 1.13 has. We may not turn it on, but we would have like the code in here. So displayio is really complicated. It's got like all of these lots and lots of arguments for initializing a display. And so displayio is complicated. Let's just... Bruce S says, so much fun, turn it on. Can I write something like decal spec aligned 4 in Python? I don't know what that does, so I couldn't tell you. Okay, so displayio is complicated. And the reason displayio is complicated is I had this goal when I was doing it that it would work if you initialize a display in your code.py. It should continue to work until you say release displays. I wanted the supervisor, the thing that runs kind of after your code is done, to still manage the display for you. And the reason that is that one of the things that beginners struggle with is finding error output, right? So your code.py runs, you initialize the display, but then you divide by 0, or you try to reference an attribute that doesn't exist. Like, I wanted to be able to reuse the display to tell you, this is where your syntax error was. It's the thing that you would see on the serial terminal. In fact, like, I have on my desktop right now. So if we go to the overhead and just look at the state of my PyPortal right now. Right, so this is displayio. And it says, for example, if you have a 5-byte size structure, then that will align it to 8 bytes. So we don't allow you to manage alignment from Python, but everything allocated in the heap will be aligned to 16. It will be 16-byte aligned for all our ports except presence, which they just switched to 32-byte alignment. But yeah, you can't do that from Python. So this works. So, well, this is a special case because it's a PyPortal. Midnight Cookie says, it's so cool you do walkthroughs of code like this. Thank you. I'm glad you like it. So PyPortal is special because the display is like built into the device. For things where that is true, yeah, I know, I'm sorry. I think I can hit, this focus does not compare to, I think I can lock it. It doesn't compare to my actual camera. So the reason this works, and the way this works is that if the board has it built in, the display is initialized in a board.init. I thought I locked it. I don't know. It's confused. Looking at screens and then there's a reflection and yeah. So the way this works is that the board init function actually initializes the display before the VM ever runs. And then it's got this terminal mode, right? You can see the Blinka here, and then it's just outputting the serial stuff. So that is all C code, and that runs regardless of whether the VM is running or not. But this is a special case where the display is built in. In the case where you have a display that you hooked up, the way that we do it is we initialize it, and then we keep it around even after you're done, even after your code's running, because we want to give a chance to be able to like show a trace back on the display that you've initialized. So there is some weirdness in that the C implementation needs to be runnable outside of the VM, and that if you initialize in the VM and then use it outside of the VM, we got to make sure that that memory is okay. So displayio is tricky in order to handle this. Now, was it worth all that time? I would say 100%, right? Because this functionality, the idea that I don't need to figure out how to run screen or teraterm or putty means, and I can see my error output is like super nice and well worth the time. So yeah, and I'm definitely your OLED AQI dev looks so cool just printing out on the REPL. That's downstairs. But yeah. So you don't, the nice thing here is also that Alvaro is pointing out is like, you can use the display without ever like having to worry about what to draw, because you can just print information as well, which is what this demo is actually doing. Having Blink on the corner reminds me of all the non-X Linux stuff I did a couple of decades ago. That might be where I got the idea. It turned out that the Blink in the corner is like really handy for making sure that your like color bits are in the right order as well. Okay, so that's some info on why it's hard. Let's talk about the naming stuff that I started to talk about. So Python is dictionaries. How does it map object dot something to another object, like a function or something like that? So type is, you can think of as what a class creates before it's instantiated, before you put the parens and then any arguments. Folknology says, can you use another free RTOS task with the ESP32-S2 running CircuitPython? You could try it. I don't know. Like, we're pretty greedy. Like, CircuitPython's in a free RTOS task, and we have our own notion of background tasks, so we don't really give a lot of time to other tasks on the system, but you could try it. If it's higher priority than us, then we don't have a choice. Like all the Wi-Fi stuff. Okay, so this is the outer level object. It has this notion of locals dictionary, which maps. So if you're given a display object, it will look in the locals dictionary for like, oh, they want refresh. So this is a mapping from string names to objects. And so let's just look at refresh. So refresh here, and then it maps to this refresh object, which is up somewhere above. Generally, I think I try to keep them in order. So here's the documentation for refresh. We have a C function, and then we have this macro. So what this macro is actually like wrapping the function pointer to there. Oh, thank you. Thank you, folks. Okay. You're not showing the code, you're teasing us. I'm so glad I'm on low latency. It would have been gone for like another minute if that wasn't true. Okay, so back to the browser. So this thing, it's at the bottom of the file, and basically all of these class files is the type. So this is the thing that, like, the object that exists before you instantiate it, before you call like bracket on it. It tells you the name of the object, the type of the object, so make new is the thing that gets called when you do the parens, that you instantiate it. And then the locals dictionary is you have an instance or not, and you do dot the thing, what does it look for? So right above that, we have the actual table for the dictionary. And it's got, this column is the strings, and then these are the values in that dictionary. So if we do here, QString, refresh, and then nprom pointer to the refresh object, and we'll scroll up. I did this faster because it's the second time. So we have the Python documentation for refresh. This is what ends up in the read the docs. And then we have the implementation of it. And then we have this np define const function obj keyword. So the first thing is the name of the resulting object. The one is like the minimum number of arguments. And then the second thing is the parameters. There's a few different versions of this. Basically, you're giving it like very coarse bounds about like argument counts and things. But that's wrapping your C function pointer in a struct that represents a Python function. And then, so depending on what macro you use to do that, you'll get a standard set of parameters in your C function based on that macro. And it will error if you get it wrong. This is kind of the most flexible style, where it's any number of arguments, both positional. So this will be the total number of arguments, positional arguments, and KW args, which are keyword args. Means that you said the argument name equals the value. And those are really awesome. You should use those in your APIs because they label the values. So anytime that you have like two ints that you pass in, if it's not clear what they are, you should make them keyword arg only, so that you always have to like do the like x equals 1 sort of thing. Okay, so this is that layer that we were talking about between shared bindings and C. So this is C code, but what it's doing is it's implementing the argument parsing that would happen in Python, kind of like to go from Python land to C land. So there's this really cool helper called parse all that does some basic translation. Julian says, do you have a recommended reference for the Python C API for extensions? I don't. I think like generally I mean, for MicroPython and CircuitPython, I would just pick the function, the existing function that's closest to what you want. But yeah, we don't have a great way of like, oh, you want to get a buffer from Python to C. Like, that would be really handy. But I don't know of a reference. For doing basic things, so this parse all is smart enough for you to say like, this keyword only argument called minimum frames per second is going to be an integer, and here's the default value of that integer. You can also say in here that it's like required and then not pass a default. It will just error if it's not been provided. So this will do basic parsing. And then this will get us... So this native display thing is so that you can actually subclass display. The object that you're passed in is the subclass instance, but you want the like C native version instead. So that's what native display does. Then there's some logic here about like the actual value we want. And this target frames per second. This is to allow, like, I think Kmatch just added this of like, if I omit target frames per second, then I just want it to refresh immediately. So this is kind of like sanity checking / tweaking the values before passing them down to the C level. So this is a very standard format. It's common HAL. So almost always what it starts with: the module name, the object name, the class name, lowercase, and then the function name. Now, if it's a property, it will be get property name or set property name. That's kind of like the standard way of doing that. And then the kind of conversion outwards. So this C level will return a C Boolean. This np obj new Boolean converts that C Boolean to a Python Boolean, which is also an object. But they have two kind of just objects that you use for all trues and all falses are the same object. Do you want me to keep going down this stack? I think we have covered it before. Otherwise, I can detour into more like backgroundy stuff. Because this is going to take the most of the time, but I think that's okay. We can always go overtime. I don't have a hard stop this week. But I have gotten less questions. I guess let me just go a little bit deeper. I won't go into details of the code. But let's go one more level. So this function, common HAL displayio display refresh, is declared in the shared bindings display.h because it's something that all implementations should have to provide. And they are, so Jeff and I were just talking about that. Midnight Cookie says we're just all taking it in. Good. I hope I'm not putting you to sleep. One of the early ones I did, Phil emailed me and said, hey, like, I watched it. It was really good. It put me to sleep. And I was like, he needed the sleep, so I was happy about that. Julian says background is great. Okay, let's just go a little bit more. I have a plan how we can get to background. So the header files here have the... MD Robert says, it's interesting, but still far from knowing where to look for register level sets of row and column. Winged Rhino says, it's a few hours past midnight here. I'm going off. Thank you for hanging out. You can always catch me on the Adafruit YouTube. They are all posted on the playlist there. And you can always catch me earlier in your day on Discord. I'm happy to answer questions. Just mention me so I see it. And weekends, no promises. But if we coordinate, then we can do it. Okay, so where is this implemented? There's two places to look for where that is implemented. Shared module is the stuff that's shared. I think that's where this actually exists. So what I quickly should show is now I'm in shared module, but you can see that all the folders are pretty similar to what's in shared bindings. That's because we basically want them to match up. So any file that you see in shared bindings, so displayio/display.c, there's a corresponding shared modules displayio.c, unless it's in common HAL, which is the other place to look. But we got lucky. It's here. So let's take a look at refresh. So here's our constructor. It takes lots and lots and lots of different configuration stuff. And then we have show and get with. And so display is a little bit different in that we have this core. So in kind of C land, we have a separate like set of objects that we use for across displays. So that's what display core is. And displayio is one of the more complicated things. Hey, that's not nice. Silly. Okay, so set brightness does different types of background or backlights or OLED. And then refreshing is complicated. But here's the top level refresh. So here's common HAL display refresh. And I hope the size of this text is manageable. I can make it bigger. So we're in the same, this is the function call that happens from shared bindings down. And the first thing that happens is this is management of timing. So if you provided a target frames per second, if you're ahead, it will wait and then refresh. If you're behind, it may skip the refresh, hoping that like it's imagining you're in a loop and you want the logic in the loop to run every frame. Right, so if you're writing a game that's 60 frames per second, and then you call refresh, either you're ahead of schedule and we refresh, or you're behind and we don't actually refresh, but we kind of just skip it. So that's what this is doing. We're tracking manual refresh, because that has timing consequences. And then we call refresh display. Make sure that the SPI bus is free, or the display bus. So the display bus could be a SPI bus, and SPI buses can be shared. And so if the display bus is not free, we just skip that refresh. Otherwise, we do a start refresh call and a finish refresh call. So start and finish, they're used to like basically inform the so displayio has a kind of like a tree of objects, right? It has, you can say on this display show this group has a number of tile grids or other groups underneath it. So start refresh and finish refresh kind of like inform those things of where we are. And there's like the refresh process is a two-phase process. One is we ask that tree, hey, what are all the areas of the screen that I need to update? So that's this get refresh area. If there are no areas to update, we're done. And then otherwise we have to refresh an area. And I think we're getting close to MD Roberts' question of where do you set column and row? Because all of this complexity here is there because for SPI displays, which is what we started with, you're limited by how fast you can transmit bytes from the microcontroller to the display itself. And those displays have memory. They have RAM that keeps all of the pixels. So the naive thing to do is every frame you spit from the microcontroller out to the display, the whole frame. But that's a lot of bits. That's a lot of data. So another reason displayio is complicated is that it's trying to be smart. It's trying to say, I'm only going to send the bits that have changed over to the display because that will be faster. The fewer bits you got to send, the faster you can send them over. So gave them the boot. Yes, indeed. So this is the ask all the tile grids and groups what rectangles of the screen need to be refreshed. And then for every area that needs to be refreshed, we call refresh area. And refresh area is right here. Furthermore, what we do is we are trying to, if you had to update the whole screen or a large portion of the screen, and we're going to compute what we're going to update it to, the buffer might be really, really, really big. And so but we don't want that. We want to minimize or like limit how big the buffer to compute the pixels we're going to send over are. So that's what buffer size is doing. So we clip the area, so keep it within the screen because groups can actually be off screen. And then we figure out, okay, for this one area we're doing, but we only want to do 128 bytes worth at a time, like sub areas of that, which is what this stuff is doing. And it has to worry about other stuff. This stuff is really complicated. It works impressively well. Like I was thinking about like Game Boy style or like platforming style where you have like most of the screen is static, but you can like have a character going. Like it works really well in that case. But there's a lot of logic around doing that. And yeah, there's a lot of code here. But this basically figures out so sub rectangles are the portions of the screen that we want to update. And yep, Folknology says the word sprites, which is a typical way of talking about it. So subrectangle is the actual piece that we're going to compute, and then we're going to send it to the display before we compute another piece and send it to the display. So to answer MD Roberts' question, the function call that we do to send the bounds to the display is this, which is displayio display core set region to update. So this is it's too long for the screen. So we give it the display core object, and then we tell it what the set row and set column commands are. We have this flag for data as commands, and then we pass it the area that we're going to update. Me6 says, hello all. I totally slept in. What did I miss? We've been asking questions. Yeah. You're doing a great job of explaining the optimizations needed to get good performance. Sprites would sit on top of this as if I'm understanding all this correctly. Right. So if you're moving a sprite, that's one tile grid, and the tile grid's like a generic version of sprite, right? Like a sprite is a case where you're taking just one image and you're moving it around, but like there's nothing stopping you from like taking that out of, like sprites tend to be out of sprite sheets, which is like a bigger image where you're taking a portion of it. And then that's the same approach that's used for like your background. So you have a big area, but the area is made up of like a number of tiles. So like tile grid is both a sprite and allows you to do the background stuff too. Yes. MD Roberts, I recognize you from that issue. So the reason MD Roberts is really interested in this is that for everyone else, if you go on Adafruit.com, we just added the 64 by 128, or is it back 128 by 64? 128 by 64 OLED. These two. This one doesn't have this problem. But they have a display controller that does really weird things. It doesn't nicely separate out the rows and columns that you're setting. Yes. Right. And I think I spent like a day on it, and I think there was two weird things about it, not just that I don't think you could set both column and page, or like, yeah, I know what you're trying to get at. I know what you're trying to get at. So this call here, set column command and set row command, are passed in because those vary per display potentially. And then data as commands is the like, sometimes there's a separate wire that is data or command. And then SPI and I2C pack that onto the transaction in the data as well. So one approach to supporting the 128 by 64 is like adding another flag that says quirk, like do this weird thing, like, and it's like pack these two things in, and then like it gets propagated down, kind of like it's this data as command thing is another example of that. I think what would help here is if we actually found the definition for this set region to update. And the way I do that is I actually just, I'm in CircuitPython here. I just do AGQ paste, and then it searches everything and tells me where it finds it. So these are calls to it from ePaper display and display. This is why core is split out, because ePaper display uses it as well. And then there's this shared module displayio display core. Now, shared modules is an implementation specific directory. So we have these like class style or class capitalized sorts of things here, but we also have these other things that are kind of just helpers. Nice. Yeah, frame buff. What utility / prompt magic are you using to get all that wonderfully useful highlighting? You're talking about the terminal? So this stuff here is... devs that work in the dark realm of command will code until 4 a.m. easy. I cannot. I'm done at 3 a.m., but that's been a while too. It's only 3:18 p.m. here, so I'm rolling. So this stuff is power line. So my terminal I use is fish, and then this prompt stuff is oh my fish, or oh my fish. It's like, oh, I've been here before. Oh my fish is a way to install stuff, and then I think it's Bob the fish. Theme Bob the fish. Yeah, it gives you exactly what I've got. Yeah, this stream is all about distraction. It's totally fine. But yeah, I like fish a lot as a shell, and then Bob the fish is really neat, adding all of that. And then the thing I'm using to search is actually called the Silver Searcher, which is AG. It's great because it does it in parallel. It's just quick. I did it at the top level of CircuitPython. That's why it took a while. But it's usually pretty quick. Can you put the links in the chat? Yes, I can. I assume you want me in the Discord chat, but I can do them in the others too. So that's the Silver Searcher, and then I'll just put Bob the fish in there as well. If I was good, I would put it in the YouTube description. Okay, so I think I've answered the questions. I have not laid out exactly how MD Roberts will get this working, because it's one of those things where I'm not going to know exactly what to do until we try it. But we're looking at display core, and we're particularly interested in this set region to update, where it takes column command, row command, set current column command, and set current row command. So there's some displays have a difference. They say, like, I'm going to write the memory in this area, And some of them will automatically put you at the start of that area when you tell them that, but other times it will be like, oh, the next place I'm going to write is here. So this allows you to have two sets of commands for that. Data as commands is like a quirk thing, along with always toggle chip select is another sort of quirk. And then the final command is the area. So there's one approach would be to figure out how to just kind of propagate some sort of quirk that says like, put it in the first byte or whatever. And then it's implemented in display core, I think. Core show. Set region to update. So it's figuring out, so the area is in pixels, but the pixels might be 2 bits, not 8 bits or more. So this is doing a like converting from pixel space to memory space, giving an option to do it. Begin transaction, that will do like your chip select on SPI, and then it will send the data. And yeah, pack the data in here. And the transaction, do the other, set the current one. Yeah. So I think that answers your question, at least when it comes to what actually sends that stuff. How we get that other display working. I think there was another quirk that made it like the other thing you have to do sometimes on displays is you have to like, you can't update on a per like byte level or per pixel level. So you may actually have this other thing that you have to do of like, you have to take the area that the tile grid wants to update, for example, and you actually need to like snap it or grow it a little bit so it aligns with the right boundaries. That's the other thing you might need to do. Okay, I'm displayio'd out, kind of. Folknology says, where does the local display image live in memory? If you have any other questions about displayio, now's the time to ask them, because I do have a couple other things I wanted to talk about, especially the UF2. I think the other stuff could be kind of quick things, but you never know. You never know. It's good. It's a good day. Folknology asks, where does the local display image live in memory? So the actual image that we spit out on SPI only lives very short. It's very temporary. We basically only compute the final version, kind of like of collapsing all the things into groups or layers. We only compute that right before we spit it out because we don't want to hold a big thing in memory. Now we have some frame bus stuff now that will hold it all in memory, but this is trying to be very memory efficient. And so it holds all the bitmaps of all the different things on the screen separately and only kind of smushes them together for the area it's updating when it's updating it. So if we go back to display and we look at refresh area, I think it's in here. So get refresh area, and then we have subrectangles and buffer. So we have this buffer, and we also have a mask, and that mask will tell us whether the pixel's been written. So what it does is it starts with a buffer of the right size that we're going for, and it has a mask saying none of these pixels have been set. And then it passes that through the groups and tile grids. They each have an opportunity to write, if they fit within that area, they write their pixels into the buffer and then mark them as done. So we don't do any sort of transparency stuff. We just say, once it's written, that's the color it is. Now, the only transparency we can do is like, you have an image, but like some of the pixels are fully transparent. Then they won't set the pixel or set the mask. So you basically let everything do that until the buffer here is either like everything had a chance or all the pixels have been set. And that is what this fill area is doing. So here you can see that mask and buffer are being set to 0. And then we pass it into fill area. What? No alpha blending? Correct. We do not have alpha blending. Here's where you would add it though. Well, nah, that's not true. You would add it to pixel buffer stuff. So if you want to add it, now you have all the knowledge you need to do it. But this was a huge chunk of code that I wrote last year. It's not at all simple. Folknology says, so would it live in the heap? No, it does not. It lives on the stack because it's right here. So that temporary buffer of the final pixels lives on the stack during a refresh. Johnny says, hi, I'm sorry I'm late. No worries. We've been talking about displayio, which I should update. Oh, I forgot to update the titles. I'm streaming as John Park on Twitch. I still haven't written my checklist. I should do that. Yeah. So we did the path if you were manually calling refresh. Let's just, there's another way that happens. Like display refreshes are automatic by default. And so how does that work? Let's just finish this. It's worth talking about. Somebody said yes to background stuff. Command says, perhaps writing my checklist should go on my checklist. I know. I like doing that because it means I could do it. So per port, is it per port? We have a background thing that we call, I think it's, yeah, so there's background.c. And it says port background task. This is a bad example because we do background stuff. We do display on ESP. We must have a shared one. Oops. Ah, hitting all the wrong buttons. Okay. So it's called from supervisor shared tick. But yeah, we had this notion of a background task, and it basically used to work where we would call it basically between every bytecode, which is really slow. And so we have some heuristics about we can have interrupts queue background tasks now. So the check to say like, so we still check if we have a task to run every bytecode, but like that check to say like, oh, we don't actually have anything to do is really cheap now, which is something that we optimized with when I did all that low power work. That was something I broke and then Jeff fixed. But basically like we needed a better way of like managing what to run. It's kind of a scheduler, not a scheduler. Everything that's queued up gets run when we have a chance. So we're in supervisor, and if we look in ticks, I haven't seen this recently. So we have supervisor background tasks, and there's this displayio background call. Now I don't actually know how we queue that up anymore. Oh, if we just turn on ticks, then it gets run. Interesting. But basically we would need a timer of like the frame rate to say like, oh, queue it up. The heck? Yeah, so there's also this kind of like top level background stuff happening. And if we just find displayio background, again, I just search for it. It's in shared module displayio dunder init. And it's just going to end up calling the refresh stuff that we talked about, I think. Displayio. Oh, nice. Johnny says, I got my Swedish translation running on the ESP32-S2. That was a cool moment. Yeah, we've done a pretty good job of factoring out the things that don't need to be per port. Um, Where's background? So background is here. Say like, oh, if MPL is interrupted is like if you hit Control C, then it's like, okay, we're done. We're going to do something more major. Same with reload request. We don't want to, if it's already going, we don't want to do it again. And then for every display, so this is actually how we handle multiple displays, which is not used that much. And then we have a top level thing that calls out to the different background stuff. This can do things like adjusting backlights happens as well here. And then the release displays is in here as well. So that's kind of how it happens in the background. Julian says, as a transitions/wrap-up, could you give a summary of what goes in shared modules, or shared bindings versus common HAL versus common shared modules? If you covered it at the start of the stream, I'll review the recording. I'll reiterate it. I did cover it earlier. Shared bindings is you always will put something there because it translates from Python to C. So it takes in your Python objects, which are all structs, and then it converts them to C level stuff. And then there's two places that you can put the C level implementation. If the implementation is agnostic, it doesn't care what microcontroller it's running on, like this code for display, like managing all that display stuff, doesn't care what CPU you're on. Then it goes in shared modules. And then, yeah, it goes in shared modules. If it's specific to a board, like it only runs on the ESP32-S2, or say it's digital I/O and there's like, you know, the way digital I/O works changes per MCU, then it goes in common HAL, which is in ports, whatever port you're talking about, common HAL / the module name / the class name. Yeah. And Command says, I appreciate you asking that, Julian, as I'm working on adding NFC I/O, I definitely was confused at first. Yeah, and Jeff's been working with us for more than a year, and he's still been asking me about that. So, yeah. So that's kind of the breakdown of those three spots. And actually, that was one thing that I wanted to do from the very beginning as I came into MicroPython, or nearly the very beginning. And one of the things also that common HAL is common in the abstraction layer, not in the implementation, which is maybe a wrong way of naming it. But yeah, that's one of the core technical things I wanted to do with when I started doing MicroPython, and something that Damien was not at the time on board doing, because I wanted the module level objects to be identical across ports, and he didn't want that to be the case. So yeah, it's something we've done from the very early on, and I think it's just worked out really well for us. It was the right call. You know, something core to CircuitPython is like having that stock standard API. Julian says, brain explosion, but I think I'm starting to get it. Thumbs up. Okay, let's move on. We just spent an hour and a half talking about displayio, which is probably not nearly enough, but it's a toe in the water. It's complicated, and only a few of us have dug into it and worked in it. So kudos to anybody who's thinking about trying, like MD Roberts. Okay, a couple other things I want to talk about. The reason that I was doing the display here is on the overhead. The reason I was doing this, sorry, I hit it. I committed a new version of requests that's supposed to work with ESP32-S2, native Wi-Fi stuff, and the old stuff. Anecdata just found out that it doesn't work with the 5.3.1 version of CircuitPython. They found that it didn't work because I had added the find function to byte array. And so what I just added to fix this, I got past it, is I added my own version of find into requests to temporarily use until we have a stable 6. And then, yeah, we can talk about the way MicroPython does it in just a sec, Johnny. From what I've seen. Yeah, that's a +1 anybody who wants me to talk about this. We could even pull up the conversation last time I looked. There's also an issue here that I changed the way that JSON module works. The JSON module would allow, in 6.0, allows you to pass in an object that has read into, but this does not. The 5.3.1 doesn't have that. So I'm going to have to also make an exception for like changing the way that we do the JSON parsing, which is unfortunate. It's going to be, I think I'm going to end up slowing everything down, but it's going to save more memory. Like the peak memory again is going to be lower, but especially in 5.3.1, like it's going to be slower, which is unfortunate. Okay. Johnny says, we could talk about this MicroPython stuff a bit. So if you want to see the background on this, there's Gitter. Or is Gitter.im? It's still around, right? Yeah. MicroPython? I don't know if you can easily get it, but I'm not signed in. I don't think it's private. Lobby. So if you go here and you just scroll up and up and up, I don't know a quick way of doing this, but you can see here's me in December 2016, which fall of 2016 is when I started working on here. You can see a discussion that we had about API design. Oh, I'm sorry. You can't see my screen again. Okay, well, I've been scrolling up on this Gitter IM. And so there's some discussion here with me and some other folks kind of about design. So if you really want all the background, this is most of the, like we had some private discussions with Damien at this point as well. You need a zapper. One thing we talked about doing was, or one thing we could consider doing is maybe like having the, I don't know if it's possible, but having the ability for someone else to control like what view I'm on. So like I can just talk and like somebody who's watching can just say like switch to desktop because he's doing desktop now. But yeah, so you can see that I'm like moving it and loading it in. And here's some discussion about API design. I think this channel is basically dead now, but all the history is still there. So if you want to just read back and see, like I think somewhere in here there is a discussion about like this idea of shared bindings. There at the time, so this is like 4 years ago, right? Almost exactly. At the time, there wasn't a good single source of like what the API of MicroPython is. Julian says OBS has a web remote plugin. An assistant for you who took some notes and timestamps would be amazing. Are you volunteering? So if somebody's interested in trying that, let me know. I'm totally open to it, and I would love. I totally recognize that like my YouTube description and all that stuff is like totally inadequate. But here's a link one thing that's interesting is that this is October 20th, 2016, and it's already a shared bindings link. Julian it is, says Johnny. Perfect. Okay, we can talk about that. So yeah, if you wanna talk about, or you want to read up on this, you can go here. Wonder if I can. There you go. I can keep scrolling and I can post a link because it's kind of annoying to have to scroll back. Oh. What was I talking about 4 years ago exactly? It's the 18th today, right? Yeah, we're on the 20th. September 20th. Oh, there it went by. Maybe I didn't do anything. Okay. I'll keep going and then share the link because the link does change. But basically, there wasn't a good source. So I was trying to add the Atmel SAMD version. There wasn't a good source for what exactly the API should be. And somewhere in this discussion, there's like, I straight up say that to Damien, and okay, here's the top. His response is like, it's a smattering of like, look in the STM port, look at this wiki page, look at this other thing. And I was just like, that is not going to work for us. And the reason it's not going to work for us is we're about to write 200 plus drivers. Well, it's now 200 plus, but like we're going to write a lot of drivers and we need it to be exactly the same. So this is where that discussion happened. Kind of that idea. The idea didn't start there, but we discussed it early on. So like here, look, I'm 5 messages in and I say, how does shared binding sound for the Pi to C code and port/common HAL sound for the C implementation? So there you go. That's where we, at least I don't know where we were discussing it before that. Maybe there's something else, but yeah, not like MicroPython. I think still is trying to be somewhat universal in their machine API, but like the PyB API still does get used. And then like there might be differences there as well. So I was pushing for it to be factored out. There's somewhere in here that's not the case. One thing, what MicroPython will do is they'll factor out at the like function level, right? So they'll factor out a function that does the Python to C level, but then they'll put that in an object that might have other stuff on it. And I didn't want to do that. That's why I'm kind of like, if you're going to turn things on and off, you do it at the module level because imports happen early and you get your errors early then. Did that kind of answer your question, Johnny? Like they have a HAL that's pretty universal. It's just not exactly universal. And it's up to the ports to make sure that they fit. I think is a fair way to say it. Okay. I talked about how I have to fix requests. We're almost out of time. So I just want to talk about these other 2 things. USB IDs, product IDs. Perfect. If you have more questions, go ahead and ask them. I can run over. I don't have a hard stop like I did last week. Let's talk USB IDs. So there's this thing called pid.codes, which is really cool. So I guess I should take a step back. Every USB device has a vendor ID and a product ID. Oh yeah, Bruce, if you could ask again, that would be awesome. Vendor IDs are like company level ID. They're both, each ID is 16 bits. So, and the way that it works is that get a usb.org/getting a vendor ID. So if you're a company, which I think is what Bruce was talking about, if you are a company that's selling multiple devices, you're Adafruit, Yes. Bruce says, I understand why Adafruit wants commercial entities to buy their own USB VID, but it seems difficult with some manufacturers, so adding boards gets stopped. Yes, this is why I want to talk about it. So, getting a vendor ID. If you are a commercial company with many devices that have USB, this is kind of what you should do. It is $6,000 upfront. I don't know if you can see that. It says, if you would like to purchase a vendor ID without signing the logo license agreement, which means you can't actually put the USB logo on your thing, the fee for this purchase is $6,000, and it is a one-time deal. So it's $6,000 once. You get a 16-bit ID, and you have 65,000 plus product IDs that you can associate with that. That's what Adafruit's done, I think. We might actually pay the other fees as well. Yeah, I don't know when it went from 5 to 6K. I actually have a change for the PID codes. So PID codes here says it's 5,000. Pay 5,000, but it's not actually 5,000 anymore. It's 6. Yeah, so this is really first and foremost a USB IF thing, right? Like, it's a lot of money up front for somebody who's putting maybe that much into making some boards to sell. Bruce S says, seems high for many companies selling boards in the hundreds or even thousands. Yeah. Yeah, and Folknology calls it the USB tax. Yes, but you have to remember, I had this issue with HDMI as well. These are technical standards. Bluetooth is like this as well, where there are people who are paid to just define what the standards are and make them. So there is value out of it, right? Like the standards are a thing that you get out of it in the end. But yes, 6,000 up front seems a little weird. HDMI is way worse because I think there's a per device fee. Midnight Cookies asks, where's the best place to talk to other people working on the Edge badge? Help with CircuitPython is a great place, but if you're not doing CircuitPython, there's other help with channels on the Discord. If you want to join the Discord, I haven't said this yet, adafru.it/Discord will get you there. So going back to USB PIDs, what are the options? You don't want to pay $6,000 for a VID because this is a one-off thing, or I'm not sure I'm going to have $6,000. Like, I'm not going to make it back in products or whatever. What are your options? I think there are microchip. I think there are places where you can actually pay them to get a PID under their VID. There is OpenMoko. I think so. OpenMoko is like this defunct technical project. They got a VID, but then the project went under. So I think that they're still there's a way to apply for one. And that's basically what pid.codes is as well. So pid.codes is somebody basically somehow got approval to use other PIDs under an existing VID that the company's defunct, and you're not they're never gonna want to reuse. Well, theory is that they'll never reuse the VID because they already kind of delegated the PIDs under that VID to somebody else. So this has a nice how-to how to get it. And then also what we've offered from Adafruit is that Adafruit has a VID and there's 65,000 spots. We're not too worried about filling those up. So that's what we've also told people is if you're open source and you're just getting started and you want to run CircuitPython, file an issue, we'll give you one of ours. Yeah. Command says, I gotta say, I kind of love Nordic's approach, which is use our VID, but we're not allocating PIDs, so hope you don't collide. Good luck. Yeah. 16 bits. Yeah, and Patrick W says, maybe the CircuitPython Foundation should have a VID for members. So we've actually discussed that. We've discussed getting a separate VID for CircuitPython. But there is a pretty big gray area where the early, like, I think the terms of getting a VID have changed where you're not actually supposed to sub-license or like give PIDs away. Bruce S says Espresso should do that, but don't. Espresso is very new to native USB, and I think that's one of the reasons I want to talk about this now, is that all of these folks coming from ESP32 or ESP land are not used to having native USB. And I guess that's another reason I should say, like, why is it important that you have a unique PID? It's a good question to talk about. It's important to have a unique VID PID pair because largely, actually, one, it allows you to identify the board. And furthermore, it can even help you identify what software is running on the board currently. So for Adafruit products, we actually allocate 3 PIDs per product. We allocate one for the bootloader, we allocate one for the Arduino, and one for CircuitPython. And the reason that is because there's some caching that host OSs do based on those IDs. So if your USB descriptor changes, like, you want to have unique keys, right? Like, the key is the IDs. So it's a good experience because PIDs are something that, like, your IDE can recognize as, like, oh, I know what this device is. So Mu will say, like, oh, you have a CircuitPython device if it has just any Adafruit VID on it, is what Mu does, but you could be more specific as well. So it's good practice to have a unique VID and PID for your product. So that's the thing I should have started with. Bruce says, this is a great deep dive into the deep today. Good. I'm glad you're liking it. So basically there's, like, OpenMoco is a way to get it. PID.codes is having some problems that I guess I'll talk about in just a sec. Adafruit does give some to folks as well, but we're trying to be better about pushing back on folks we see who are selling their stuff. We think that there is a point where you're selling enough stuff that you should have your own VID. Like, that is an investment that, as a, like, owner of a board business, you should pay. If in turn, yeah, right. Adafruit paid it. Other folks should pay it too. That doesn't mean that you can't go to an alternative to do it as well. Ooh, and Bruce has a thing for microchip. Let's see what microchip says. Yeah. Unexpected Maker asks, what level does Adafruit think that is? I don't think that there's a clear level. I would say that we might push back on you more if we hadn't already given you some. I was thinking about this. I think it is kind of the, like, if you quit your job and are doing it as your sole thing, I think that's kind of the point, right? Like, if you're doing investments at that similar scale, then that's kind of where I think people should do that. In the Discord chat, you go to adafru.it/discord. There are a number of ways of getting product IDs that folks are pointing out. So this is like the microchip one. And maybe it doesn't even cost anything. I don't see the instructions. It says just request. So you have to say, like, so vendors will have a way of giving it to you too, is what Bruce is pointing out. So wouldn't a number of unique boards be more engaged than a number of sales on a board? That's a good question. I think it's more like, it's not necessarily like sales or the number of boards. I think it's actually more a, like, how much investment are you putting into your company? right? So like a VID makes it formal, makes it benefit more people. Yeah, I'm talking in general and not outlining specific Adafruit policies. Yeah, so as somebody who is able to give out PIDs for Adafruit, that's why I'm kind of like, I think we're gonna try to be a little bit stricter on people that we see selling products. Whether you buy a VID or get it from somebody else is a separate thing. There are no private VID PIDs for the stained glass non-routable IPs. Want to play around with building and designing my own board, but don't intend to sell it. Okay, that's a good transition. Let's talk about PID.codes, because this is the place I think I'm going to end up pointing people. It's got this great website here, and you can see all the organizations. You can see all of the PIDs. This is also just like a Jekyll thing. And you can just click here. So they require you to be open source. So open source hardware and software. If you're running software on somebody else's hardware, then I've been fudging it. But it's pretty neat. It has this, whatever company had this 1209 VID. The person who started this knew them and said, like, these ranges are reserved, but everything else is fine. The problem is that the person's kind of disappeared. I think got a little bit overwhelmed with the popularity of it, but that's just my guess. So if you look at pull requests, there's 44 open, and the last one was April 22nd from Zobs. So if you look at this, we can see that there's like lots and lots open. I know that both Command and I think somebody else said that they're both waiting. So we've had a couple issues where I've like pointed people. So the other thing I should say. So in CircuitPython, I added a PID check. So we will actually now verify it's in tools, CI check duplicate USB VID PID. So we have a couple cases where we do duplicates. But generally we want to make sure that no two boards in CircuitPython have the same PID. So this is checked in, this is running now, so more people are going to hit this. I had to go back and allocate some more PIDs because we had some that I didn't think should be the same. Bruce says, I know a company who has a VID for 3 products. Oh, perfect. Yeah, and as far as if you're closed source, I don't know what to tell you. Like, I guess I would look at what Bruce is talking about of like sub-licensing from the chip vendor that you're using for USB. So I guess that's a place to start if you're not open source. If you are open source, there's this pid.code site, but there's a lot of stuff pending. However, because I want to point people to this, I actually started my own pull request, which actually merges in all the pending stuff into my own branch, basically to make sure that nobody collides. And I can now actually just do all the reviews myself. And I got one email back from the creator of pid.code, so I'm hoping that I'm going to hear back again. And basically, if they merge this aggregate PR from me, it'll close a bunch of open PRs. So I did that this week as well with the CI stuff. And so you can see all the pending ones. By the time I opened it, you can see kind of like what I said about their project and whether I merged it or not. Yeah, he did answer me. I think he said he would like help. And then I like immediately replied, like, what do you think about this? And then I didn't get anything back. So in terms of what I accept into CircuitPython, if you have it merged into this branch that I have, I'll accept it into CircuitPython. Basically, I think the way I'm going to do this is like, I'm trying to help. I'm trying to get these all merged in. Like Jeff opened an issue. One of the issues here is also like, can we help just do all these merges? And it's got 9 thumbs up. And I also said like, hey, like, I had this open PR. So if you want a pid.codes one to use in CircuitPython, create a PR to my branch, the aggregate PIDs one, and then I'll accept it, right? Like, I don't want you to be blocked on waiting for CircuitPython. I don't want you blocked waiting on the person who has merge access for pid.codes. So yeah, and Bruce says, I guess what happens with all the various companies making ESP32-S2 boards and don't care about getting a vid or even a PID. This is why I'm doing this, is like, I expect the S2 to be really popular. I expect it to be done by a lot of folks that don't know or care about USB VID PID stuff. So it's going to be a mix of like either pid.codes PIDs, or also if you are like core to the circuit, if you're participating in the CircuitPython community and need it, like, we can gift those as well. Yeah. Johnny says, last time I checked, the agreement with the USB consortium prohibited you from handing out IDs. Yeah. Yeah, and I think it's not at all exactly clear what they will do otherwise as well. Because you want to be cautious, right? Like, you don't want overlap. But anyway, so that's my answer. If you're open source software, and CircuitPython is open source software, if you're open source hardware, you can get one from pid.codes. If you're part of the CircuitPython community and need it, reach out to us and we'll see what we can do. But yeah, that's the USB PID stuff I wanted to talk about. Any other questions about it? Lots of discussion, and I think it's something that, like, a lot of people are new to as well. Yeah, so Bruce says, I was doing a board def for the Steddle Things board, but got stopped. Yes. So if you're doing a board def for somebody else's board, like, just, we can pid.codes it, or we could do an Adafruit one. I think for Adafruit, we're going to stop giving Arduino PIDs. So we'll only give probably only bootloader and CircuitPython ones. Julian says, super interesting discussion. We'll watch 2 hours in and later have to drop out. Okay, we're going to talk. I just want to touch on the, I want to talk about USB or UF2 just briefly as well. Thanks for hanging out though, Julian. I appreciate it. And if it's 2 or I guess if it's late enough for you to go to sleep, maybe we'll have to find somebody else to do the remote control stuff. Okay, let's talk UF2. And this is actually why I had the hover cam going. Because I think this is also something new to ESP folks, and I just want to make the pitch again for UF2. So so what is UF2? What is a bootloader? I guess that's the best place to start. A bootloader is a piece of code that lives on the device, usually in a way that you can't erase it, and that if anything else is... Oh, okay. Julian is same time zone. Perfect. Client dropped in. All right, cool. Okay. Yes, so bootloader. And I think this is one of the main innovations of Arduino, actually, is that they had a standardized bootloader that was easier to use as well. So a bootloader's job is to communicate in an easier way to a host computer than the like native way of like SWD or JTAG. So a bootloader like Arduino bootloader used, it was probably UART. It probably wasn't even USB, but it was a UART protocol that allowed you to flash the other part of the chip. So bootloaders are really handy because they make changing what's on the chip more accessible. And the Arduino one was like core, I think core to Arduino. Like there's also the like language and the IDE, but like the bootloader, the fact that you could just buy the board and you didn't need a separate thing to do a separate piece of hardware to interface, I think is one of the core innovations that came out of Arduino. So that's kind of what Adafruit used for a long time. And then around the time that CircuitPython started, there was also some stuff happening in Microsoft around embedded things. And they were doing make code. And make code requires you to flash every time. And they came up with... I'll have to find the email again, but I remember getting the email of like, hey, we invented our own file format. It's called UF2. And it was just like, oh, why are you inventing your own file format? But it's actually really clever. So what it allows is with native USB, which is like relatively new, Bruce says Embed was the first one I saw that used the disk emulation thing. So this is the innovation with UF2, and Embed does this as well, but I think Embed does it weirder. The idea is that everybody, like people know how to use a USB thumb drive, right? Like they know how to use, like, here's one I have on my desk, right? Like you plug it in. See, I'm not on product showcase. That's why it's blurry. You plug it in your computer, you see the files, you drag the files over, right? It's super easy. And Embed did it, but they had to play a lot of tricks because they allowed you to just drag hex files over and bin files. So I think there was like some reliability issues. I haven't actually used it that much, but I think that they had to play a lot of tricks. And so the reason that UF2, the innovation I think that UF2 did was the idea that the USB protocol that this runs off of transfers data in 512 byte blocks. So you're guaranteed that even if the blocks are copied out of order or in a different rate or whatever, like, you know that you're going to get a 512 block at a time. And so what UF2 does is it takes a binary file, a .bin file, and it explodes it out so that each 512 byte block has fewer bytes of actual binary, but it also has metadata about like which block in the whole chunk it is. So you always know where to write it. And it also has like checksums and magic numbers and stuff. So that's why when you convert a binary to a UF2 file, you see it get bigger, is that it's just exploding it out and having metadata at 512 boundaries. So what happens is that the drive that shows up is actually fake. It gets synchronized, or it gets cached by the host OS potentially as well. So you drag the file over and you drop it, and then as those 512 byte chunks are written, they get written straight to the spot on the flash that they end up with. So that's why UF2 is really cool, is that it's very easy to use. It's reliable because the UF2 format stuff has all this metadata in it too. And so if you ever see like the error that says like, oh, you ejected the drive too early, like, it's fine because UF2 knows exactly when it got all the blocks it needed, because every block knows how many total blocks there are and what block you have, which is really cool. And there's links in the Discord if people want to follow up on more information for UF2. So that is another reason that native USB is really great, because if you have a bridge chip that's just doing serial, you can't do like mass storage drives. And so where are we at on the ESP32-S2? Espressos themselves, they're used to this process of non-native USB, right? They're used to just doing serial loading. So that's what their focus is on. But because with CircuitPython and everything we've taught people with Adafruit, it's all about the drive. Command says my forks of UF2 bootloaders end up with sleeps after the flash finishes to try and let the OS realize it's finished the copy because of that too soon removal. Yeah. Yeah, the device can't be like, no, really, sync, I'm about to go away. You can't say that, which is so unfortunate. But let me show you what we've got. I think what I actually want to do is I want to switch to desktop with overhead. And I showed it earlier, but I've got, we won't go too much longer. Obviously my voice is getting tired. So what do I have under here? It looks very yellow. So it's a Sala with a rover on it, and and my version 3 of my adapter to Feather. It's got native USB here, and then this is a dev board from Espressif, and this USB here is not native. So what I want to do, and the guide that I have to write, is teaching people how to get the UF2 bootloader onto their device so that they can use the UF2 bootloader going forwards. The way you do that on a Sala is that you could just use the non-native USB to serial converter chip to load it. That's what I did earlier today. So if I just, I'm going to plug in the native, but the LED should, the LED doesn't light up. And let me show you here. So here's my, it's not working. I don't know why. I'm on the native side. Anyway, so the LED's not lit up, but if I double tap reset, it's red, which you definitely cannot see. I don't know why you can't see that. But it's red here. And I think it's because like I'm using this new USB 2.0 port, and like Linux is still unhappy with me, I think. Like for some reason it's no longer like, this is my USB cable and it's orange, which means it should be connecting. So I should say, for those new to UF2, if this red is, or if the status new pixel is red, that means the bootloader is running, but it was unable to connect over USB. So I'm going to just power cycle or plug and unplug my host, or my hub chip, my hub. And it's really unhappy. I unplugged and plugged it in, and now it's just, luckily there's like a status light on this hub. I could try it on the other hub too. Is Linux USB just terrible? I was hoping this other hub would be better. Yeah, it doesn't work. It's just red. Okay, let me use the other hub under here. See if that one's working. All right, there we go. So if I re-click it, it's purple for a second. Now it's off. And it disconnected. I don't know what the deal is. Something's messed up with my USB. That might be a bug on our side. Like if I I'm trying to, you can't see it. So the light is off, or the light is green. But if I click it on, it starts up and then it turns off. Like it might be that like I'm negotiating the wrong like power level, maybe, and like the hub is like actually shutting me down because of my power level, maybe. It's just not happy with me. So what I can do here is actually, the problem is I don't have any, when I blip this cable, it makes it so that I lose power, which is unfortunate. But I can double tap reset, and it still hates me. I was doing this earlier, I swear. It was working. I'm trying it in the other hub again. Because it turned weird. It's white now, but there's no power to the USB at all. I'm just failing today. My USB, like my Linux USB stack is just so unhappy with me. I don't have this problem with when I'm on Mac. Like, okay. Like there's got to be some sort of USB bug that's causing trouble. So let's see if I double tap reset here. So there we go. So I double tapped reset so that the second time I hit reset was when it was purple. And I don't think you can see that at all, unfortunately. So it's red right now, which means that the USB is not actually connected. It was working earlier. So the other thing that we're going to do is, so the double tap of the reset button requires an RC circuit, a capacitor and resistor, which on my version 3 of my adapter from Salad to Feather is just right there. It's just, all it does is in the time when it's purple, it sets the value on the capacitor to 1. And then if you reset it, that 1 stays long enough that it can read it again. I know. I don't know why it's not showing up. The other thing that we're supporting with UF2. So the problem is that if you just reset it, it goes to UF2, but then it doesn't go to UF2, but it just runs the code that's flashed on it. So the question is, how do you get back into bootloader mode? And for most of our boards, it's double tapping reset, but that requires that capacitor and resistor. So what Tack added, who wrote this bootloader, is he also added the ability to do a quick reset then boot. So if you hit boot during the time that the RGB LED is purple, which you can't see, but if I just do a now I'm in the bootloader again. So that means that like the UF2 should even work on other boards as well, which is cool. I don't know why my USB stack is so unhappy. It might be because like all the cameras are like, I have 2 USB 3 cameras going, hopefully still. Yes. Command says, does the S2 not have any sort of power survivable registers? Correct. So the reset button on the S2 is a power enable line. So if you have reset pressed down, all of the chip turns off and you lose all state. So the reason that trick usually works is on like a SAMD, the reset line just resets the CPU. It doesn't actually reset memory. So what happens is that we set a value during the like purple time. And then if we start up again and we see that value already, then we know we double tapped. Okay, I'm unhappy that the USB is not cooperating. OSPark isn't that slow if you get the super speed, or whatever they call it, the double the price but faster. But yeah, we had to do that like 1-bit thing. Yeah, Mr. Blacksea says, why am I subscribed to this? Yes, other folks at Adafruit did a number of 3D printing, like Zelda stuff. Okay. What about getting power from the other non-native FTDI port? Yeah, I could do that. If I have a second cable here somewhere. I don't think I'm done. I'm toast. I'm not the Zelda person. I do Game Boy stuff. Good night, Mr. Blacksea. And yeah, I'm both trying for the USB. I'm trying on the CircuitPython hub, and I'm trying on the pluggable hub that gave me trouble last week as well, which I usually can turn off and on and it behaves better. But most of the time I'm not running two of these high-speed cameras either. So that could be it as well. Let's just try it one more time. But yeah, I mean, if you can't see the LED either, it's unfortunate. But it does work, which is great. So I guess I can just talk about what I'm working on. I'm going to write a guide so that it's clear how to add board support for the bootloader for you, for new folks. And I'm going to, here's the repo. It's UF2 ESP32-S under Adafruit. May actually get a PS5, but the urge will wear off by the time it's available. Yeah, so I have my own fork of this, and I'm adding support for different flash sizes, which is something that Unexpected Maker Sion actually asked for. So that's checked into CircuitPython, but now I need to get that working with the bootloader as well. So we'll have different partition layouts for 4, 8, and 16 megabyte flashes. I wanted to double check this, and I needed to better document the RC circuit. So I was very happy that this works. So I'll draw that up and tell people what the pins are. In fact, I will just scroll down and show you what I'm talking about. So it says like, here's when it's purple, you can either hit boot 0. We can add a 128 megabyte flash mode. Basically the 8 and the 16 are the same start, and then it just has longer user flash for file system. I actually changed it between the 4 and the 8 though, because I'm really worried about running out of space for CircuitPython. So with the 4 megabyte version, it's like 1400K, but I just made it 2 megabytes for CircuitPython for the other two. But yeah, so I'll update this README. I will add the multi-flash support. I'm going to test it just with Unexpected Maker's S2, because that's the only ESP32-S2 I have with more flash. So I'll use that for testing. Microdev has been a huge help as well. Microdev is the maker of another board that also has 16 megabytes. So they tested the CircuitPython changes and said like, yep, it works. And they also actually, they're working on, not to get you too excited, but we were talking earlier on Discord about deep sleep support for CircuitPython. So the ESP32-S2 might actually be the first CircuitPython port to support deep sleep. So another topic, but it's kind of exciting. So let me just show you this. So I did that initial work for sleeping just when you do time.sleep. That doesn't work if you want to wake up not based on time, but based on like a pin input. So there's two issues here that I just updated. What did I use to search for them? One is called hibernate. So there's basically two levels of sleep that I want to support. One level is light sleep, meaning everything still runs, but like the CPU may be off. That what characterizes light sleep in particular for CircuitPython is that your code.py keeps running because RAM stays. RAM and like code support stays. Deep sleep, or in what I'm calling in here hibernate, is the opposite, where you're in such a low sleep state that you shut CircuitPython down. You like power gate your CPU, so like the transistors of your CPU are not getting any power, your RAM's not getting any power. Only the things that will wake you up are still powered. That's typically called deep sleep. So Microdev, they're great. They added support for the temperature sensor on the ESP32-S2 and wanted to do deep sleep. So we had a discussion earlier today or yesterday about this. Here's the API I'm thinking of for deep sleep. And then here's the link to the light sleep example. So I'll just show these off because I'm excited about it. I think you'll be excited about it. If you have opinions, now is the time to have opinions on API. So the way that light sleep works, in the case where you want to sleep for a given time, like time.sleep should be what you use. If you want to wake up on a different thing or time or a pin, here's what I'm thinking. You have supervisor, and then you have one alarm module per type of alarm that you can support. So if your microcontroller can wake up when a pin goes high, that's a pin alarm. If you want to do it based on time, you have time alarm. And that would change based on the reason it's at the module levels, because it might change from microcontroller to microcontroller. So this is what your code would look like if you're doing a light sleep based on these things. So you say while true. So you're going to stay in this loop, sleep until one of these two things happens. It returns the alarm that woke it up. So you give it multiple alarms and it returns the one that woke it up. And then you can say, if the alarm is the pin, then I did a pin change. If it's alarm that is time, then I can print the time or do whatever you want based on it. That's what it looks like with light sleep. So that's RAM is being preserved. Your code.py just runs. How do you change that if your code.py is stopping? Well, you import the same things. You can read active alarm. So that's the thing that started you up. You create the same two alarms, and then you can compare the alarm that woke you up to the ones that you just created. And then you tell the supervisor, hey, like these two alarms are the ones I want to wake me up next time. And then you just let your code finish. That's kind of dramatic. But the idea is that like deep sleep stops your code. So it shouldn't work until you stop your code. So that's why this is no longer a loop. Like this is the inside of your loop now. And that's what I'm thinking for the API. Microdev is working on it. No promises because it's not high on my list or any of the other Adafruit sponsored ones. So if you want to support this work, support Microdev. But we're talking about what the API should be. So if you have opinions on that, let us know. So yeah, Microdev's been great. And yeah, I think that's it. I think I gotta stop talking because my voice is tired. Thank you, everybody. It's been a pleasure to hang out with you all. We've got lots of really good conversations in this 2.5 hours, as always. If you want to reach me or any other CircuitPython-y folks or the folks in the chat when we're not streaming, you can go to Command is watching. We talked about this. Hold on, I have one other thing I want to show. Maybe it's just a teaser. So I don't think there's a good way of doing lots and lots of pins out of a development board. I don't like doing pin headers for lots of wires. So I've been working on using, so I really like, yeah, you reminded me. Okay, the overhead's on. I really like these 2x5s that are used for SWD. I think they're perfect for 1 byte at a time. So power, ground, and 8 data bytes or 8 data bits. So I want to move to a model. So I do like some retro computing stuff. So like a Game Boy cartridge is 32 pins on its own. So how do I prototype interfacing with that? How do I prototype interfacing with a key matrix for, like I have a number of like piano keyboards that are from the 80s where I want to like leave the chip in there that produces those 80 sounds, but intercept the key matrix so that I can either like stop it from playing when keys are pressed or like mix in keys being pressed with what you are and stuff like that. So I really like this idea of like a byte level format. And then the question is, if I want like lots of bytes, how do I get access to those bytes? So I've been prototyping, and I told Command this. We are also working on the debug edge stuff. But I think one way to do it is actually to use an edge connector. Connectors I like because you pay the cost on one side of the connection and not both. But I'm working on a board that breaks out from a PCIe compatible, like physically compatible but not electrically compatible board. So let me I'll 3D viewer that. So this is a prototype that I have that's not finished yet, but it's 30 pins and it's designed for this half-size breadboard. So what it would do is this board would go along the outside edge and basically connect to all 30 rows on one side of it. And I'm thinking of an FPGA. So I'm thinking of the Mach X02s in particular because they're I2C. So this prototype that I'm working on that I'm not done with yet this is where the PCIe connector goes. So you would have, yeah, you have the overhead. Oh, that's right. You couldn't see me hold it up. This one. So it's designed for half-size breadboard. So the idea is that this board that I'm showing the 3D render of would sit over one power rail for the whole length of the half-size breadboard and basically digitally, like signal-wise, connect all 30 rows, in this case, to an FPGA. So moving to a model of like designating bytes. So I haven't labeled it yet, but maybe you can see it here, that it's like A0 through A7, B0 through B7, that sort of thing. And then breaking out just a few things kind of that you always want broken out from the dev board. So this is stemma in and out, and then I'm going to add USB as well. And I'm adding USB because I also want SAMDs in this scenario as well. So my Game Boy cart is, I have a PCB here. So it has problems. It's not perfect. And so what I'd really like to do is be able to prototype this cart in two pieces. Like I want to have the cart and the logic level shifters, and then I want to put the SAMD. This is MIDI stuff that I'm not doing. It works just fine. But the SAMD I want to put on a separate card. So I'm thinking about how to like do these like broad parallel sorts of stuff. And I think PCIe is great as a great way to do that because it's higher density. You can see the comparison here between like a breakout board, breadboard versus PCIe density. There's a whole byte here on the PCIe connector that I'm not even breaking out. So I think PCIe is the right way to go. I think it's interesting because PCIe comes in 4 sizes. It comes in 1x, 4x, 8x, and 16x. The connectors just get longer, but they're compatible across each other. So this is a 4x footprint, for example. So yeah, that's another thing I'm brainstorming is using like breaking out some of the support circuitry off of the like actual dev board, allowing you to swap it in easier. So like the 3.3 voltage regulator is here, so you don't need that on the device itself. Xmost used the PCIe connectors for breakouts. Yeah, and the other thing, Command has been helpful finding some of this other stuff. Maker Diary is doing some interesting things. They've actually been really helpful with CircuitPython Sleep as well. They're doing the N2 Maker Diary. So Maker Diary is doing some really interesting stuff. They're using the M2 form factor, which has its history versus PCIe. And they had this idea, basically, I had this idea as well earlier, but they actually did it. using M2 is a way to like swap the brain out of a larger system without having to redo the larger system. So like one of their other products is this keyboard. And so like the brain is on this M2 card. You can see it here. And I think I may have talked about it, but it's like keyboard PCBs are really big and expensive. So like if you want to be able to swap the brains of it, you really want it on a separate card. So I think that's when I was thinking about it, was when I was doing circuit or keyboard design. So it's really cool to see that they did that. And so I think that there's a role for the PCIe connector to do that as well. But then potentially like shrink the same sort of pinout down to an M2. Okay, I think that's it. Any questions about that before I really finish? John likes it. Cool. Well, advantage is they are quite inexpensive as well. Yeah. Yeah, so like that's why I look at like edge connectors that are in all these desktop computers. They're readily available, they're standardized, and they're really cheap. Yeah, it's a great spot to look at. It's kind of, you have to be careful. So like I printed out the Wikipedia pinout for PCIe Express and made sure that like the high voltage, like 12 volts pins, like I just don't use. So like even if you happen to put like whatever we call it, and if you have ideas of what we should call it, like if I happen to put one of these dev boards into a PCI slot, like at least you won't fry it, but it may not work as PCIe. So support for M2 drives on SAMD. That's a whole different thing. I doubt you can. So the problem is that you get like these higher speed technologies like PCIe, they use high speed serial lanes, and they're like 2.5 gigabits per second, which like a SAMD just can't keep up with. Like, and HDMI is the same way. Like you can't support those things you get in a computer because their interfaces are just way too quick for a lowly, like 100 megahertz sort of thing. Yeah, it'd be cool. I mean, that's what SD cards are for. Like if you need lots of space, SD cards are the way to go. The other thing I want to do is do HDMI bare metal Raspberry Pi, which, was it last week that we talked about this? I guess, it's been a week and a half from CircuitPython Day. But I did find, just keep you going. There's a really good Raspberry Pi 3 bare metal. This tutorial. So this is what looks to be a really cool tutorial. Raspberry Pi 3 tutorial for doing bare metal Raspberry Pi. I think some of you were telling me this on CircuitPython Day. But it's really neat because like tutorial 9 is frame buffer. And it turns out that like all of the display stuff is initialized by some like binary blob that you have to use. So it's actually like relatively easy to get stuff outputting on the HDMI display. So I mean to, when I have some time amongst all of my other projects plus my work, this is something I'm really interested in, is trying to get CircuitPython running bare metal on a Raspberry Pi, which would be cool. And I think we'd have to use Bluetooth for keyboard and mouse and stuff. But I was actually sitting down in front of my TV going like, I would want wireless because you're not going to want to be right close to it. So yeah, if anybody wants to help me with getting CircuitPython on the Raspberry Pi 3, let me know. That would be cool. Ryan says, I've been playing with the green pack and they might useful as I2C to retro IO adapter. They even support 5 volts. Yeah. They don't have a lot of logic. I think that was my worry, but I think for that form factor of like I2C set of IO sort of things, where I think I've showed it. When did I make this? My projects. Like this, I should have on show and tell at least. Like this design, where it's stemma in out and then a byte here and a byte there. Like this form factor could be nice for like kind of like high IO stemma stuff. Okay, for reals, for real. It's been great. Thank you all. Obviously, we had a lot to catch up on. I'm Scott. I work for CircuitPython, or work for Adafruit on CircuitPython. You can go to adafruit.com, support folks there, support Adafruit there. They pay me to work on CircuitPython and stream to you and talk about all this stuff, including the stuff that's not CircuitPython. It does inform CircuitPython, so that helps. And if any of this is really cool, it'll be an Adafruit product as well. If you want to hang out with me and a lot of other cool folks around hardware, join the Adafruit Discord server, which is adafru.it/discord. That will drop you in there. We're there all week. I try not to be there too much on weekends. Yes, thank you, David. David's saying next week, I'm planning on doing it on Thursday, so we're going to be a day early. We have house cleaners and window cleaners coming next Friday, so my wife is like, why do you do that when we have people here? So next week we will be on Thursday, not Friday. So we may start a little late because depending on how long JP goes. But we'll basically go right after John Park's workshop, who I think he starts at 1 p.m. Pacific. So hopefully the same time, 2 p.m. Pacific, just a day earlier. And yeah, support Adafruit. They support me. And they make lots of great open source software and hardware. So every bit helps. So, and if you see things like sensors that are really cool that you'd love to see from Adafruit, I think a lot of you have your like fingers on that pulse. Let us know. We're always looking for new sensors, new microcontrollers, new things to have as Adafruit products. So if there's things, let us know. And if you want to help with CircuitPython, we're always looking for folks to help contribute. You can reach out to me directly on Discord if you need guidance on how to do that, or just have like a hurdle to get over. I'm always welcome or there as well. Some folks posted my OshPark links. All the hardware I design is open source as well. So if you want anything that you've seen, it may not be available from Adafruit, but you can at least order it and assemble it yourself. I'm not great about BOMs, so like bill of materials, so just let me know if you need to know what parts go on things. And with that, I think I'm going to call it. I'll keep chatting with you all in the Discord, and we'll see you next Thursday. Thank you, David, again, for the reminder to remind you that it's not on Friday next week. Have a great weekend, everyone. We'll see you on the Discords.